Okay, Drew here. Been working on the heat detector cold activation issue. I've got a Fire-Lite panel set up here and a couple of devices connected. These are the same ones I had connected. This is an H355. This one's on point 10. I've got an H365 on point 11. And I've got it connected to a detector over here that I've taken apart. And I really think I know what's going on with these units. So when you look at these detectors normally, this is how you know. I really actually want to know something too. So hopefully if somebody sees this, they can give me some information here. Because when you come in here, read status, system point, detector. So I've only got two detectors on this system right now. One I was on 10, which is this one, and one over there is on 12. So it's normal. And it gives me this detector status 0.27. So, that's the lowest that this seems to go. So this is an HT detector, SD 355. Geez, 355 HT, the old style. You can tell obviously from the dot. So it's 0.27. So I don't know. What I'd like to know is what temperature does that represent? When does it jump to 28? Is it 72 degrees? Is it 85 degrees where it starts ticking up, or what? But basically, I know, once you get below some value, going colder and colder, it doesn't go down any further than that. So if it's like a normal room temperature detector, it seems 0.27 tells you, yeah, this is a high temperature device. Whereas if you connect a regular device, those seem to, their baseline point is 0.42. So you connect an H365 or a 365R, it's 0.42. If it's an HT device, it's 0.27. So that's how I can tell, from, the screen, which one of those two I have. So I have 10, which is 0.27, and I have 12, which is 0.27. So sitting normal, everything's happy. So the scenario is, of course, we have these attic heat detectors which are tripping in the cold, and we've gone through, we've made sure we have, done the SLC configuration. So, we're pretty confident that the panels are out there seeing them all as high temperature devices, which they are, correctly. So there's not a type confusion in this cold thing, and if there was, it would make it worse, honestly. But here's what I think is happening. So you got these townhome units. They are probably all of them connected with gas-fired furnaces. Definitely, they're all natural gas-fired furnaces, insulated, probably pretty decent insulation. But even still, you've got this warm, moist box, and gas-fired furnaces definitely help keep, decent humidity in the wintertime. So it's a warm, moist box, basically. And you've got, the detector in the attic, which is not heated. It is, it's cold, but it's just above this warm, moist box. And presumably, some of that moist air, a little bit, leaks into this attic. I think a little bit of it probably does. So I think that something is happening, and I think what it is that it's really cold, and a little bit of this moisture leaks up there, and it leaks onto the terminals of the device. So I have two here. I have one that I totally took apart. So let's just look at this one for a second. So this is the 365 series devices. They all seem to have this little plug-in connector here for the thermistor, and there's no coating. I mean, the leads on this are totally coated and protected, so you can see that. But then that wire, the whole thing right there, it's not. Let's see if I can zoom in even more. Hey, look at that. So that's just totally bare metal right there, and there's not really much of a gap on the bottom. Maybe there is a little bit underneath there, and they're pretty close together. It's looking at the other side. It's kind of the same thing, and on the bottom, and this is kind of exposed, but it's those two terminals right there. That's how they look coming from the factory. So, they've been soldered on there. I don't know if they're soldered separately in the process, but they do. I don't know, maybe it's just my camera, but they look darker, like maybe they had a soldering iron on them. I don't know if they do that, to put that device in there manually, like a human does that. You guys obviously know the answer to that question. But there's no kind of coating or anything on this. It's just exposed. So this brings the... I actually swore when I saw this, because what I think is happening, before I tell you why I swore, is I think this side of this is totally exposed on the inside. There's no protection from this at all, which is fine. But I think there's just a little bit of dust that settles somewhere on there, maybe some dust, and then maybe when these attics get super cold, they got that warm, moist box, and those little pieces of metal right there are cold. So the water in the air that's seeping up from the moist condo or townhome below condenses on those little terminals, and maybe these things are probably sitting in the attic sideways. Maybe they're like this. It's possible. The orientation, I'm not sure how they end up. They're probably all different orientations. Maybe some are like this and some are like this. But either way, if there's just enough capillary action with the water that it's sticking in there behind that block, it could even be freezing in there. Obviously it is cold, so it condenses. There's probably just some sweet spot. Just a little bit of water gets in there. And here's why I swore, though. So let me pull up. This is an old one. See the old style 355. Would you look at that? They don't have the little block. It's totally different. So they had a manufacturing change on this. This one, it's hard to see there. I'm not focusing very well. But clearly, I think that the gap is bigger, and then it's soldered in, but it's like some kind of it's definitely not a block, but the gap is a lot bigger. So here, now we're gonna do what I think's happening. Oh, one more thing. This is another one that I had here in the shop. I was gonna open it up and look at it, but the thing that I noticed about this one, sorry, too many things to look at here. I opened this one up, and it's just, look at that. See how it's a little dusty? That was just sitting around. Even in the cap here, it's dusty. So this is what I'm saying, is that dust in any of these buildings, they could all look like that up in an attic when you open them up, and there's a little dust like that. So, who knows how much dust settled down in there on that. And when it can, it gets wet, you can see dust on the thing right there. Look at all that dust. So, I don't think this one was in any place other than just sitting around the shop for a while, but when it's in here, it's that dust gets right through that opening. It's right into this, settles on there, and then a little moisture hits it, and it sucks right down in there on the base, on those metal contacts. And here's the real kicker. So 0.27 to alarm 10, 0.27 to alarm 12. So let's say that dust is in there. The temperature and humidity just get just right in this attic. We're just going to go back here, get out of there, no battery. But I have a device over here where I have connected this it has the thermistor in there like normal, and right now I have a little. This box is called a decade resistance box. So these are all connected in series. So if you want it, you can really have any resistance value you want, which so it's awesome. I use it all the time for testing. So right now I have it at 1 mega ohm. So that's 10 or 100,000 kilo ohms. So it's no, that's a mega ohm. Yeah, 10 times 100. Yeah, so it's a mega ohm. And I have this dial on 1, and I have this dial on 5. So that's 1,500 ohms, 1.5 K plus a mega ohm. So I just have it at mega ohm. So it's like this is open circuit. And what I have is I just have a couple of leads stabbed in there. If you can see them, they're just kind of stabbed in there and clipped on the thermistor. So I think this is what's happening, is that little bit of dust, conditions are just right, a little bit of moisture, it drops in there on that somehow. It gets those metal contacts in there, collect a little bit of moisture, it pools in there on the contact or somewhere on the board underneath it, and the resistance drops. There's a slight resistance. It's not a dead short by any means, but it doesn't have to be a dead short. I've just determined this has to drop to around 1,500 or 1,600 ohms, so about 1.5, 1.6 K, so between those terminal contacts. So all I have to do is turn this dial down to 0, and we'll be at 1,500 ohms, so 1.5 K. I'm going to do that now. So we'll turn it down to 0. So now we're at 1.5 K. We've just simulated a little water droplet from condensation and maybe some dust. Dust would help the if it's pure water, it's not conductive, but if there's a little dust in it. So we'll give this a minute. I think it seems like the percent to alarm updates about every 60 seconds. But I'm pretty confident we're going to have some action here. There we go. Look at that. Look at that. So, I think that's it. I think this connection is the culprit. I think they either need to change this to a more permanent connection like the other one had. Maybe they separate the terminals, somehow make it so that you can't have a connection between these points. Another option might be to spray some kind of conformal coating over it to protect it. I don't think it's the backside, but who knows? I mean, anything's a possibility. Could this backside here, have a weak connection? But could a little bit of moisture get on that? I don't know. It seems much more likely to me that it's in this big connector here, and there's those are kind of relatively big metal pieces that are cold, and if the humid air gets on them, just enough moisture kind of drips down inside. I don't know if I can zoom in more. Not really, but kind of get right underneath there in that tiny little gap. Focus is not very good, but I think you might have saw what I'm talking about here. There's just a tiny, tiny little gap on the bottom there of that yellow connector that maybe it just gets in there, dusty, dirty water, which is just barely enough of a conductor to make it 1.5 K, or something less, and boom, alarm. I think this is the problem. I have no doubt. I don't know. The solution has to be some kind of a change to that connector. So, go back to like the old connectors on the SD 355 HTs, or change this connector to separate the pins so that they can't get connected to each other with a little tiny moisture underneath them, or seal the whole thing with some kind of a spray-on conformal, silicone coating or something. At least on the HT detectors. This shouldn't be, it's not a problem when it's hot because you're not going to have condensation. It's not a problem on detectors that are mounted inside a building because you shouldn't have condensation. It's a problem in cold spaces. That's it. And that's got to be the cold activation. It's got to be it. Anyway, I appreciate any comments. I do have another video with a different problem I discovered, but it's more of a manufacturing thing. I will post that one later. Thank you.